Today's daily code problem of the day is maximum sum of distinct subarrays with length k, number 2461. For this problem, we are given an integer array nums and an integer k. For the maximum subarray of all the subarrays of nums, they have to meet the following conditions. The subarray has to be the length k, and all the elements of the subarray have to be distinct, meaning that each element in the subarray has to be its own individual number. There cannot be duplicate numbers. So we want to return the maximum subarray sum of all the subarrays that meet the condition. If no subarrays meet this condition, we will return 0. The subarray is a contiguous, non-empty sequence of elements within the array. So the elements have to be in order, not manipulated, and it has to be non-empty. So if we look at example 1 here, we have the nums 1542999 and k is equal to 3. So first we'll initialize, before that, we have to recognize that we're going to have subarrays of length 3. So first subarray is going to be here, and then we're going to have a subarray here, and then here, so on and so forth. And within those subarrays, we want to check a couple things. First, we want to check its sum. So right here we have 10. And then we got to make sure that there are no duplicate numbers, because we have to make sure all the numbers are distinct. So how do we check that there's no duplicate numbers? Well, we're going to use a sliding window technique. So our goal is to find the maximum possible sum. And to use the sliding window technique, we are going to basically initialize the sliding window to be the first couple of numbers. Initialize the sum to be the first couple of numbers. So we have 1, 5, and 4. And we're going to use a hash set to ensure that all the elements are distinct. So we'll add each element. We'll start at 1 and then expand to 5 and then expand to 4, adding each number to a hash set to make sure they're distinct. After we check 1, 5, 4, we will shift over the sliding window. So we'll increment n by 1, increment back by, or start by 1, and then our new sliding window is going to be 5, 4, 2. And then we'll increment again, 4, 2, 9. And then we'll increment again, 2, 9, 9. Well, now we have 2 occurrences of 9. I accidentally circled 3. Now that we have 2 occurrences of 9, because it's already in our hash set, it'll tell us this element already exists. We'll skip this. We'll increment again. And the last subarray is 999, multiple occurrences of 9. So again, it'll tell us, hey, can't do this, and we'll move on from there. So let's go ahead and jump into the code. First thing we're going to do is recognize that we're returning a long variable. So we're going to initiate a long max sum. This is going to be initialized to 0. We're also going to have a long current sum, which will initialize to 0. And then we're going to initialize our hash set, which is going to store integers. And we'll call this our unique. This is all of our unique elements, and it's a new hash set. Finally, we'll initialize a variable called start, which is simply just going to be the start of our sliding window. Now, to initialize our starting window and add them in our current element, we're going to move end all the way to our end value throughout the entire array. So for integer end is going to be equal to 0. It's going to start at the beginning. As long as end is less than our nums dot length, then we can increment end. Now within this for loop, we're going to have a while loop and an if statement. The while loop is basically going to check and add numbers to the unique elements hash set. And then our if statement is going to check to make sure that our window size is still of k length. So our while loop, while unique dot contains our nums of end. This is basically us trying to get rid of the middle element. So let's say we are in this position. Well, we have 2 9s. we don't want to get rid of this 9 because that one's brand new and we don't know how much longer in the array it might be going. So we are going to move our starting point, which is over here marking 2. We're going to move our starting point from 2 to 9, and then, oh, hey, this is the number that we're looking for. So we're going to get rid of this 9. We're going to get rid of this 2, and our new window is just going to be this single 9. Now that we have a window that's only 1 9 in length, we can expand it to the next element, and if this wasn't a 9, then it would continue on from there until we have another valid window or reach the end of our array. So we're going to have unique dot remove nums of start, and then our current sum needs to be updated as well, subtracting that value from this current running sum. And then we can increment start to be the next value in the list or the array, and we'll check again to see if we have a fixed array. Then we are going to add whatever our end value is to our unique elements. So unique is going to dot add nums of end, and then our current sum will also be updated with nums of end. Now we're going to check if our window size is valid. If our window size is not valid, we cannot add this to our total. We have to ensure that we have a subarray of at least k. So if end minus start, and then we're going to add a 1 because it's a 0 indexed array, meaning that the first element is index 0, second is index 1, third is index 2, so on and so forth. So as long as n minus start plus 1 is equal to k, then we have a valid subarray. Our max sum can be updated using the math.max, and we're going to pass it our previous max sum and our current sum. Now we are going to remove the elements at the start to slide the window. So this is a case scenario where there is no duplicate numbers. We just added and updated our max sum, and now we're going to increment without having to worry about duplicate numbers like up here. So we're going to unique dot remove our nums of start and current sum minus equals our nums of start, and start will increment again. And that is it. That's all we have to do. Now we can return our max sum. This effectively traverses the entire array using a sliding window technique. If there's duplicates, we handle our duplicates right here, allowing us to move forward in the array. So if we have 1, 2, 3, and then 3 again, 4, 5, and our start is here, our end is here. So once we evaluate this section, we are then, or the subarray, we are then going to move our subarray to the next elements. So our start is going to increment to 2, our end is going to increment to 3, and we have 2 3s. Both these 3s are already in the hash map or our hash set. So something's going to go off. It's going to return false or return true, and then what we're going to do is we're going to move s from here. We're going to remove this element from our set. We're going to move s from here to here. We're going to move this element from our set because this is the matching element, and then we're going to move s from here to here. And then what we'll do is, since s is equal to e, or the start is equal to the end, we'll increment end here, and we'll continue to do that until we have a valid array again, which is going to be of length 3. So boom, now we have our new subarray. And that's it. That's how the code works. Sorry. So if we run this, pass our test cases, and if we submit it, it passes all solutions. Thank you. Follow for more daily LeetCode solutions. Check out my Instagram. Check out my TikTok. Check out my bio if you want to learn how to code. And that's it for today. See you tomorrow.